evaluate the double integral, and we want to evaluate 3x plus 4y. X and y lies between 0 and 1. So if I want to, I can either write it in this form, or I can also write it in this form. Fortunately that 3x, x and y, fortunately x and y are symmetrical. So that makes it easier for me. And I'll use the same rule of moving outward from the center. Meaning that if I start with dx, then I'll use the first limit of integration. So I want to integrate that with respect to x. It will be 3x squared over 2 plus 4xy. And I want to put the limits of integration as 0 of 1 dy. And that will give me 0 to 1. When x is 1, this becomes 3 over 2 plus 4y. Then I integrate with respect to y. So this becomes 3 over 2y plus 2y squared, 0 to 1, which is 3 over 2 plus 2, which is 2, 3 plus 4, and the answer is equals to 7 over 2. Integral of 0 to 2, 0 to 1, e of 2x minus y dy dx. Note that takes us to 0 to 2. We want to evaluate this with respect to y, so we differentiate the power and then we divide with it. So it is e raised to power 2x minus y, then minus 1, 0 to 1 dx. This gives me 0 to 2 minus e raised to power 2x minus 1 minus e raised to power 2x dx. Because I'm substituting whenever there is y, I replace with 1 and also with 0. And therefore, that gives me minus, I'm going to differentiate with respect to x, that is 2 raised to power 2x minus 1 over 2 minus e raised to power 2x over 2, and the limits of integration are 0 to 2. And what does that give us? This takes us to the point of negative e when x is 2, 4 minus 1 over 2 minus e raised to power 4 over 2. Then minus e raised to power 0 minus 1 over 2 minus e raised to power 0 over 2. So that's what we have, and therefore this will give us a half e raised to power 3 minus a half e raised to power 4 plus a half e raised to power minus 1 minus 1 over 2. And that's the equation that we have, and I can factor out 1 over 2 to make it look simpler. So it is a half. And this gives rise to e raised to power 4 minus e raised to power 3 minus 1 plus 1 over e, and that is the final solution to that equation.